Hello, my name is Dalen Wilson and I'll be explaining to you the main functions of our code that we wrote for the Arduino Uno force sensor project. First, I'll give you a little background on the Arduino Uno software. First, the Arduino microchip board and software is very vital to our success in executing our objective of getting our pressure sensor to work. The exact purpose of the pressure sensor is to convert digital signal from analog signal when pressure is applied to the sensor. In this section of the foundation, we learned the background of sketching. A sketch is the name that Arduino uses for programming. It is how the Arduino board is able to run the uploaded code of units that is implemented by the code writer. Similar to most software, you can include comments in your code such as a memory message. It also can be for the person writing code to explain what is he or she is trying to get the program to do. This is a great tool for product developers to come and advance the code. Another characteristic of this software is variables. A variable is a place for storing a piece of data. The advantage of variables is that it is easy to manipulate the data that the variable is assigned to, which can change the output on the board. It is often discussed that the value of the variable might change while the sketch runs. Function is a named piece of a code that can be used for elsewhere in a sketch. There are ways of calling functions that have already been defined in the code, either in your sketch or as a part of the Arduino language. These parameters can be used by the pin mode function to decide which pin and mode to set. The pin mode function configures a pin as either an input or an output. When configured as an input, a pin can detect the state of a sensor like a push button, but as an output, it can drive the actuator like an LED. There are several other functions that the sketch section, but I only discussed a few. I'll talk a little bit about the microcontroller. The first section discussed in the microcontroller section is the digital pins. The pins are configured as either inputs or outputs. An important piece of the info that we first want to consider is that vast majority Arduino analog pins may be configured and used in exactly the same manner as digital pins. Arduino pins default to inputs so that they have no need to be explicitly declared as inputs with pin mode. Pins configured as inputs are said to be in a high impedance state. Since these input pins have extremely small demands on the circuit that they are configuring, it is equivalent to a series resistor of 100 meg ohm in front of a pin. It takes a very little current to move the input pin from one state to another, and can make the pins useful for such tasks as implementing a capacitive touch sensor, reading an LED as a photodiode, or reading an analog sensor with a scheme such as RC time. Some of the main functions I want to tell you about in our code was basically the initializing of the interfacing pins, which we used to include. We had to include the liquid crystal .h for setting up the pins to connect to the Arduino LCD. Then we had to have a string state, which stated that it was a safe mode, warning, or danger. The setup function was only ran once, and then we had a void loop which was continuously running. And then if the voltage was higher than the danger threshold as stated above, then the danger LED would turn off and other LEDs would turn on. Also change the LCD state to danger, so you would read that out on the LCD. And if the voltage is higher than the warning threshold as stated above, then the LED warning would turn on and off any other LEDs that were on. which also set a Boolean to true, which also changed the LCD state to warning, so it would show warning on the LCD. And if those two conditions weren't working, then we had an else statement, which the voltage is lower than the warning threshold or higher than 0, then as stated above, the LCD would turn the safe LED on, and you would see a state of safe on the LCD. This was the main function of our microcontroller for the Arduino Uno software.
So I'm going to be talking about how the force sensors interface to the signal conditioning amplifier or ACC circuit. So to amplify and make use of the force sensor, a signal conditioning is required. Here we have a simple ACC circuit with the force sensor in between the inverting input of the op-amp and the VT. And in this particular op-amp that we used is the LM324N. After doing research and experimenting, we found out that that was the best op-amp to use for this application. One of the advantages that it has is that it can be powered by using only a single power supply, which is 5 volts, and using this configuration no RI is needed. And the reason for that is because as force is applied to the sensor, the resistance actually goes down, which acts like a voltage gain. So let's take a scenario, and let's say we wanted to have an output of 5 volts on the V out, and we're going to use this formula to figure out what RS would need to be, or what the resistance, or in other words, how much force we need to apply in order to get a 5 volts output. So by using this formula, we're gonna set VT to -5 volts. RS is unknown, which we are trying to find. V out is gonna be 5 volts, and RF, our feedback resistor, is gonna be 100K. So here we have the formula, 5 volts output, VT, RS, and RF, and we're gonna find RS. And as you can see, RS is gonna have to be 100K as well, because that's the maximum force that we're gonna apply. The maximum force applied to the force sensor is 100K. So RS is gonna be